Hi everyone, this is Deekshit. Welcome to my channel. In this video, the idea is to discuss about the tasks that I'd worked on in previous project so that it'll gonna give you an idea how the DevOps work might look like. This might help who have started the career in DevOps or people who want to start the career in DevOps. And also I would like to say it's not that you're gonna get the same task that I'm gonna discuss in this video. Tasks might definitely vary from project to project, organization to organization, and tools involved in the project. Now, without wasting any time, let's get started. And prerequisite to watch this video, you should have a basic knowledge on DevOps tools like Docker, Kubernetes, Helm charts, Ansible, Jenkins, shell scripting, Git and GitHub, and as well as monitoring tools like Prometheus and Grafana. First, let's start with shell scripting. First shell scripting task that I want to discuss is related to JFrog. Before telling what the script is about, I want to discuss about the problem statement. In one of the project, we were using JFrog, which was running on the internal cloud machines. In that artifactory, we used to store Maven artifacts, Docker images, Helm charts, and many other artifacts as well. From the same artifactory for the CI, we used to download Maven dependencies, Maven plugins, Node packages, Python packages, and depending on the source code, we used to pull other packages too. Also, Docker images, Helm charts, which will be created as a part of CI/CD pipeline, were also pushed to the same artifactory. On the flip side, Kubernetes cluster, which was running on the internal cloud again, was connected to the JFrog to pull the images and to deploy the application. But in the beginning of the project, number of microservices onboarded were very less, and managing K8's cluster and as well as JFrog was not challenging. But once we started onboarding many services from multiple teams, it was quite difficult and tricky to manage Kubernetes cluster and as well as JFrog. So that's where client decided to move on to the public cloud. Once that decision was taken, we got few clusters created in public cloud, but there was one problem with the JFrog. The JFrog had a lot of artifacts, due to which the migration of JFrog was not easy and it was bit time consuming as well. So that's the reason client postponed JFrog migration onto the public cloud. But till then, the plan was to pull the images from internal JFrog onto the public cloud K8 clusters. Few applications teams started deploying the applications, but they were complaining about the image pull was too slow. It was expected because JFrog and K8 clusters were there in the two different networks. JFrog was there in the internal cloud and K8 cluster were there in the public cloud. To solve the image pull time issues, we came up with one more idea to have a NGINX as a reverse proxy plus cache, which will be running in the public cloud and pointed to the JFrog, which is running in the internal cloud. And K8 cluster, which is running in the public cloud, will be pointed to NGINX. So now with this setup, all the image pull request from K8 will be sent to the NGINX. Now NGINX will gonna check the cache. If the image is present in the cache, then it will be served directly from the NGINX. But if the image is not there, so then the request will be redirected to the JFrog. If any image which is not there in the NGINX cache will be directly pulled from the JFrog internal cloud and served to the K8 cluster. And also after the image pull is done, all the image layers will be cached in the NGINX. Because of which the first pull will be always slower, but further pulls of the same image will be faster because already all the image layers will be available in the NGINX cache. And this is where we wanted to write a script which will read all the image names from the JFrog, which is running inside internal cloud, and pull the images via NGINX machine to fill up the cache, so that application teams will not face any latency issues while pulling the images onto the K8 clusters. And this script also had a logic to check whether the same image is pulled twice. What will be the time difference between the first pull and the second pull? And parallelly, we had one more script which will be executed on daily basis, which reads the newer images from the JFrog and pull the images via NGINX. And this script also helps us in filling up the cache. Though it was a very small script, but it was very important to reduce the image pull time. And it is not necessary that you're going to always be involved in the big scripts. The script might be smaller, but it is very important in perspective to the project. Second shell script task that I want to discuss is again an artifactory. Problem statement is to store artifact information in JFrog, we need to have a database. In our case, we were using PostgreSDB, which was running inside the Docker container. Actually, running DB on a container is not correct, but whatever the machines that we had, on top of that, we could not bring up the standalone Postgres due to some OS mismatch issues. So that's the reason we went with a container. As artifact information was very important, we add a master slave concept enabled so that we don't lose any information. And whenever there is much load on JFrog, if we have master slave concept, we can serve the request in the faster manner. But there was one issue. In the master container, we had a script which will create archival files. These archival files are used in the replication of data to slaves. But due to some issue, archival files were not cleaned up once the replication is done. So this was filling up the master container memory very faster. So that's where we wanted to have a script which will clean up the archival file on regular basis. So that's where we introduced a shell script. What it does is for every 5 minutes, the script will gonna run and it will gonna check whether archival file count is more than 100 files or not. If it is more than 100 files, so then it will delete the older archival files. And to run the script for every 5 minutes, we had used a cron tab. So we have scheduled that particular script to run every 5 minutes. So by this, we could able to free up the memory for the master container. Third shell script task that I want to discuss is related to GitHub. Problem statement is, I was working on a migration project where we were migrating the build tool from Maven to Gradle. But we observed that there were many unused branches in all the application repos, which was not good. So our manager wanted a report which will have the information about repo name, branch name, which doesn't have any commit since last 2 months, and also the name of the person who has created that particular branch. So that's where by using a GitHub APIs, we implemented a shell script which provides the report, which will have the information about name of the person who has created a branch and the repo name, as well as branch doesn't have any commit since last 2 months. After which the report was shared with all the dev managers, and with their approvals, we wrote one more shell script. Again, by using GitHub APIs, we deleted all the unused branches. Fourth shell script task that I want to discuss is related to GitHub again. Problem statement is, in the same migration project that I discussed in the previous task, developers were not following any proper pull request template while raising a pull request, which is not correct because recommendation from the product owner of that particular project is to link it with Jira ticket or any task ID, which might help him to audit or show some progress to higher management. If you don't know what is Jira and pull request, Jira is a tool where all the tasks are defined, will be assigned to the individuals to work on a specific task. Later, individual developers or an engineer will update the ticket about the progress in the task. On the other hand, pull request, in a simple terms, if you want to say, if a developer want to do any change in the code, he can't directly do it on the master branch. So developer has to create a new branch, push his or her changes onto the newly created branch, even if it is a smallest of smallest change. After which code has to be merged onto the master. So before merging it onto the master, it has to be reviewed by your team members and senior team members. And as well as there will be some pipelines, which will be making sure that your changes won't break the master branch code. To both for review and also to make sure that your changes won't break the master code branch, we need to raise some request for this review process. That request is called as pull request. In the GitLab and Azure repos, we will call this review process request as a merge request. So to make sure every developer follows the proper pull request template, we implemented a shell script which will be executed automatically whenever there is a new pull request created. If he or she, developer, DevOps engineer, or whoever is the contributor for that particular repo, doesn't follow the standards, then pull request will be blocked. So until unless they follow a proper pull request template. So by which we made sure that all the pull requests are tagged with task ID and a proper title for the pull request as shown on the screen. Fifth shell script task that I want to discuss is related to JFrog. In one of the projects, we were using JFrog extensively, where few admin activities like repo creation, getting reports of all the repos, deletion of repos, and adding a specific user to a specific repo, and many other admin activities were repeated. So all these activities we wanted to automate it by using shell script. So wherein only admin will gonna provide few inputs, and by using those inputs, so shell script will be executed to perform some admin activities like repo creation, deletion, adding a specific user to a specific repo. And also we should always keep in mind if any task which is repeatedly executed manually, and that is a better candidate to automated by using any scripting. It can be a shell script or it can be a Python script. So by which we can increase the productivity. Now let's discuss about the tasks related to Git and GitHub. First GitHub task that I want to discuss is we wanted to move a repository from GitHub to GitLab, including branches and the commit history. If both GitHub and GitLab is on the same network or a domain, we can move it easily by using the options which are available in the GitLab UI. But in our case, GitHub and GitLab were there in the two different domains. So that's the reason by using UI options, it is not possible at all. So that's where we had to use the options which are -bear and -mirror. First, what we need to do is by using git clone -bear and GitHub repo link. So when we execute that command, it will gonna download only meta info about the repo, which are branches, commit history, reference to the actual files, and many other files as well. And once those information has been downloaded, so next command that we need to execute is git push -mirror and GitLab link where you want to push. So when you execute this command, all the info, meta info, will be pushed to the GitLab repository, and that particular files will have the references to actual code files also, right? So in the UI of the GitLab, you will be able to see actual files. So that is how we migrated by using -bear and -mirror options. And we need to remember one more thing when we go with this with -bear and -mirror. So you need to make sure that all the pull requests or the issues in the GitHub should be closed, because in the GitLab, by using -bear and -mirror options, we will be able to only push the commit history and the branches, not the pull request and also the issues. You can't transfer the pull request and issues at all. Next GitHub task or activity that I want to discuss is, it's not always that you work on some bug or implementation. Reviewing other team member work is also very important. If you see that other team members code changes can be improved, then you should always comment on their pull request as shown in the image. Also, reviewing can help us in understanding others' code and other strategies, which might definitely help us in future tasks where we can take this implementation and put it in our task, and we can do it our task as early as possible as well. And one more thing to remember, even when we do changes, we might also get some comments to change or improve the things. If those comments are valid, so then we need to consider that and do the changes accordingly. And sometimes we get a comments asking some clarifications. Even those clarifications has to be given by us, and we need to make understand the other person why we are trying to do some changes. And once these comments are resolved, then only the pull request or merge request will be merged onto the master. And once it is merged, then only we can mark some task as done. If the pull request or a merge request is not merged onto the master, so then we won't consider that as a completed task. That's where reviewing plays a very, very important role in DevOps activities. Third task that I want to discuss in Git and GitHub is reducing the clone time. So we had one repository, so which was very huge, was more than 5 GB. And while cloning that repository in the pipeline, it used to take more than 10 minutes. Because of which developers, test engineers, and others who are dependent on that particular pipeline was complaining about the clone time. So think about in this way, if it is taking 10 minutes to clone, and also to build, it might take much time, and as well as like to apply the test cases and other stages was also taking much time. And so that is where wherein like we wanted to reduce at least the clone time so that we can improve the time consumption in the pipeline. Before discussing about the steps that we have taken to reduce the clone time, so I want to point out few more things. By default, whenever we clone a repository, all the branch information, commit history, and as well as other meta information about the repository will be downloaded. And if you are wondering where this particular information will be downloaded and stored in the local file system, so when you clone a repository with the repo name or the folder where you want to clone the repository, if a user provides that folder name, so under that folder name, all the files in the repository will be downloaded, right? So in the same folder, there will be one more directory which is called as .git. Under that .git, so we will have a couple of other folders where we will have the information about branches, commit history, and many other meta info about the repository. Now let me show you. So I've cloned one of the repository. You can see that by using a git clone and the repository link and the folder where I want to clone this particular repository has been given. And also I'm executing git clone command with the time command to check how much time it is going to take to clone the entire repository. You can see that it has taken 14 minutes, nearly 15 minutes it has taken. And when I go inside CD and also the folder where I've cloned the repository, I've did a CD kubernetes -local. And after that, I've executed du-sh. So when I executed this command, the total size of that particular repository, so which is basically 1.2 GB, you can see on the screen, it has been given to me. And so once I got to know the total size of the repository, I did ls-la, and this is where you can see that there are many directories which is called as like .git, .github, .git attributes, .generated files and all. So, but I'm interested in this particular folder. When I cd'd into that particular .git directory, you can see that many other folders like hooks, info, logs, objects, references. So this is where all the information about branches, commit history, and many other meta information about the repository will be stored. And again, if you see here, I executed du-sh. You can see that 917 MB is used for this .git directory itself. And out of 1.5 GB of my total repository size, so 917 MB will be occupied by this .git folder itself. And after getting to know these things, and we investigated and we spoke to developers who were running the pipeline, so we came to few decisions that they were not interested in all the branches. So they were interested in only one branch, which was master branch, and which was used in the pipeline. So that's the reason wherein we went with -f single branch, and we made sure that only the master branch is downloaded. Now let's execute git clone with this particular option, and let's see how much time will it gonna take. Let me go to Visual Studio Code, and we will gonna clone the repository with this particular option. I'll gonna create a new git bash window. So here I'll go to one of the empty directory that I have. So training, and under this I'll make sure that no folders are there. You can see that no other folders are there. So I'm gonna use a git clone command, and with the option single branch, single branch, and I need to specify which branch I want to download by using -b, and I'm providing the branch name and the repo link. Let me go here, and we need to click on this code button and then select this HTTPS link. And also I'm going to execute this command with time command, so that I'll come to know how much time it has taken to clone this particular repository with these options. Repo has been cloned. You can see that it took 9 minutes 18 seconds. And as well as when I went into the repository, and when I checked the size, it is almost the same. But very important thing here to observe is number of objects it is trying to download. In this case, you can see that 1,25,000 odd number of objects that it has tried to download. But when I downloaded the complete repository, in that case, if you see, it is trying to download 1,37,000 objects. So that's where we are. In this particular case, the number of objects it is trying to download is less. So that's the reason it took very less time. But there is no change in the size of the repository, because the master branch is a major branch. It might have a lot of commit history. So that's the reason there is no much variation in the size. But this is also wherein considerably wherein it has reduced 5 minutes. But we had come across a couple of other options by which we could able to kind of reduce even more. And before discussing about that option, we can see one more thing. See, when I executed git branch -a in the repository where I cloned with these options, you can see that only master branch is there. But when I go to the repository where all the branches have downloaded, as in like the plain clone, you can see that when I execute git branch, you can see that there are a lot of branches. So because of these branches only, the number of objects that we are trying to download when we do a normal clone is being more. Now, let's see the other option where we can reduce time even more. Let me go back. I'll do cd ... And let me go back to my slides. And the next option that we want to discuss is -FN depth. So by using -FN depth, you can specify how much commits that you want to download or how much commit history that you want to clone it when you execute git clone command. And when I provide -FN depth 1, so it will gonna only clone or download the last commit, which will have all the code. It doesn't mean that when I give -FN depth 1, I'll gonna miss out some actual code files or something. So we're gonna still download all the code files. It's just that commit history that we don't need it. Let me go to Visual Studio Code, and I'll gonna include this -FN depth option as well, and let me execute it. And I'm gonna use -FN single branch as well, that option with this -FN depth option. And -depth 1. And also now I want to clone this particular repository onto a directory, which is called as kubernetes -commit. You can give any folder name. I'm just giving it as kubernetes -commit. You can see that git clone has been completed by using this -FN single branch -B and as well as -FN depth 1. Now the reduction in the clone time, you can see that 56 seconds, 9 minutes to 56 seconds. So this is great, right? So now what would have happened is, let me go inside this Kubernetes commit repository or a directory. And here when I type in du-sh, and you can see that the size of the repository which is cloned, which will be kind of like gradually reduced. You can see that only 344 MB. Now when I go inside .git folder, and when I execute du-sh again, so here you can see that only 42 MB. But wherein in case only when I used a single branch, right? So that time, let's see how much it would have been. So let me go inside Kubernetes. So previously with only -FN single branch and -B option I've cloned, right? I'm going to that particular folder and I'm checking what will be the size of that .git directory. du-sh. So when I execute, you can see that 862 MB. So when I compare it with this and also -FN depth, you can see there is a gradual change. So that's the reason whenever you are not interested in commit history, so then you can use this -FN depth and you can reduce the clone time. And this is also one thing, but in my case, for an example, I've taken this particular repository, which is of size 1.2 GB. But in our case, it was even more bigger repository. So even -FN depth was taking much time. So that's where we had used one more option, which is -FN references. The way -FN reference option works is, let's assume this is the machine where we want to clone the repository. Before that clone or pipeline run itself, we would have downloaded the repository onto a specific location. Let's assume that location is /opt/local repo. And now whenever the clone is executing or like the pipeline is executing, so we would have executing the pipeline run or like the clone step with the option -FN reference and the repository where already it has been cloned, means the location of the repository which has been already cloned and the clone link. Now this time what will happen is, first it will gonna copy all the object, whatever which is there in the directory which has been already cloned onto the cloning repository. Let's assume if the pipeline is running, the pipeline will gonna clone the code onto some workspace directory in the Jenkins, right? So there, all the objects from this local directory will be copied onto the workspace directory. And is there any updates? Like it will go and check, is there any updates in the remote repository? If any objects which is not there in the local repository, so then only those remote updates, it will going to take it from the remote repository. That is how it will going to work. And for this, one extra workaround that we need to do for all the machines where we are executing a git clone, we should have downloaded this particular repository into the location opt and local repository. So when we go with this methodology, so it gradually reduced the whole clone time. So now let's see, let me go to Visual Studio Code and let me execute that particular command. So let me go to a new Git bash window. And now Let me execute that particular command. Let me go to again directory where I was executing the commands. And this is the command. You can see git clone -f single branch and -f depth as well. And you can see here I'm giving -f reference also. And I'm giving the reference to the repository. So here, if you remember, I downloaded the old repository into this location, right? So that's the reason I'm giving that particular location. And I'm giving the git clone link. And I'm providing the directory name as kubernetes-reference -1, or like you can give whatever the folder name that you want. I can just maybe give it as kubernetes-ref. So let me execute it now. Now you can see that like how much time reduction it will have. So plain clone was taking around 15 minutes, and then -f single branch, it took around 9 minutes. And when we went added -f depth option, it got reduced to 50 seconds. And now, so we are executing with -f reference. Let's see how much time it will get reduced. Now you can see the repository, this location, whatever the files that add, the objects that add, so which is completely, wherein like the complete repository objects which are there. So now all the objects will copy from this directory to the directory which I want to clone it, which is kubernetes-ref. It will gonna copy. If there is some change in the remote repository, so in this repository, then it will gonna download it. If there is no change, so then it will gonna copy objects from one location to another location. You can see that now from 50 seconds, it has been reduced to 28 seconds. So this is how, by using these options, wherein we have reduced the clone time gradually. And also we did one more R&D. So as I said, depending on machine specifications and the internet speed, the clone time will also vary, right? So we had did a little more R&D on different machine types and different throughputs of disk which is attached to the machine. And then we suggested Jenkins admin team to use a specific instance type so that even the build time and the clone time will be getting improved. So all those suggestions we have provided to Jenkins admin team as well. Now let's discuss about Ansible tasks. I've used Ansible for installation and configuration purposes. In one of the project, I was administrator of JFrog Artifactory. The installation and configuration were made manually. So due to which, whenever there is a downtime of JFrog, or in cases of adding extra node to any of the JFrog component, or in cases of upgrades and rollbacks, so we used to take much time because it requires manual intervention. So sometimes we have observed that due to manual intervention, few config steps were missed, and again we had to restart all the steps from the beginning. So which is a lot of rework, as well as we shouldn't have much downtime for JFrog because it will be connected to many important tools like Jenkins and Kubernetes. So to avoid these issues, we have automated all the installations and configuration steps by using Ansible playbooks. And coming to JFrog, if we want to make JFrog as stable and production ready, so then we need to have components like Artifactory, X-ray, machine control, distribution, and edge nodes. So let me give you a brief about each component and architecture. So then you will come to know why playbooks were very important. First component is Artifactory. So it is used to store and manage all kinds of artifacts like Maven packages, Python packages, Node packages, and also containerization binaries like Docker images and Helm charts. On the other side, so Jenkins CI/CD pipelines, developers who want to connect with JFrog to execute some APIs or to download any packages manually, all those developers will be connected to JFrog, and as well as Dev and QV Kubernetes clusters will be connected to pull the packages and images to deploy the application on KH cluster. And the next very important component is X-ray. X-ray is the component which proactively identifies the vulnerabilities on open sources and as well as license compliance violations before sending manifest or artifacts to the production releases. So X-ray is in a basic simple terms, if you want to say. So this is the component which will gonna identify the vulnerabilities and any license compliance violations on artifacts. So if any violations are there, so then it will be reported to the respective team and it will be deleted after some grace period. And also as soon as artifact is uploaded, so that particular artifact will be scanned and the report will be visible in the Artifactory UI itself. And the next component is machine control. Machine control is a single access point for managing multiple services or components like Artifactory, X-ray, edge node, distribution. So in simple terms, I can say that a machine control is for monitoring or managing all the components of the JFrog. And the next very important component is edge node. So edge node is same as Artifactory, but it is readable instance. So that means we can only download the artifacts. So you can't upload or like you can't write anything onto this edge nodes. So usually all the production artifacts will be stored here. So all production clusters, whatever the Kubernetes production clusters will be there, right? So those production clusters will be pointed to this edge node to pull the images and to deploy the applications on K8s cluster. So that's the reason you should always make sure that edge node should be always up and running. So now you might have a doubt how the artifacts are considered as a production level artifacts and also how the artifacts are copied to the edge node from Artifactory components. So in our case, we had one API. So once the QA testing is done, the respective teams will mark a specific artifacts as a prod artifact by adding specific custom tag. So once that tag is added, so there used to be one more component in JFrog, which is called as distribution. That component will gonna read the artifacts, whichever has some custom specific tag, timely basis. So whatever the artifacts that which will have that custom tag, so that those artifacts will be first copied onto the edge node. So that is what the usage of distribution. In a simple terms, if I want to say, distribution helps in copying the files from Artifactory component to the edge component. Also, very important thing is all the components should have a database to store artifact information. It can be Artifactory component, it can be X-ray component, or it can be distribution component. Every component should have a database to store artifact information. So especially for Artifactory and edge node, we should have memory attached. So it can be any big data store like S3, GCP buckets, or any internal storage solution. So that will gonna help Artifactory and edge node to store actual artifacts. And now with this diagram in mind, you can assume how complex it is to maintain JFrog manually. Also for each component, there were so many steps that we need to execute it to bring it up each component. So now let me show you the steps that we require to install Artifactory, X-ray, machine control, and distribution. So this is the JFrog official documentation. You can see that there are so many steps that we need to use to bring up each component. So this is for Artifactory. And likewise, I have opened for like X-ray and machine control and as well as distribution. There are so many steps. So maybe what I'll do is I'll gonna provide these links in the video's description. You can go ahead and you can check out more details about all these JFrog components. And also one more thing is in the JFrog official repository, we had found out that they have written Ansible rules. So in our case also, we had referred these rules and we have not completely copied these rules and we have automated our installation and configuration. We have used a few concepts which are there in this particular playbooks and we have wrote our own customized Ansible playbooks to bring it up because we had couple of secondary instances and the database that we were using was totally different. So that's the reason we had written our own playbooks. I'll also provide this link also. You can see that there are so many roles for Artifactory, distribution, insights, Postgres, and as well as like X-ray. Also for databases, we wanted primary and secondary instances to maintain high availability. For this, again, we had used Ansible playbooks. In addition to that, so we had enabled high availability concept for each of the component. So that means for all the components like Artifactory, X-ray, distribution, machine control, edge node, we had multiple instances. So in that multiple instances, one will be primary and other instances. If we have multiple other instances, those will be secondary instances. So here the idea is if the primary goes down, so still the secondary will handle all the requests. So that's where we wanted to keep our Ansible playbook execution very simple, because if we have multiple playbooks, admin will get confused and it might impact many other things as well. So this is where we wanted to use a single playbook. So that should bring up component with both primary and secondary instances. To achieve this, we had used concepts like delegate to, Ansible variables, answering custom prompts by using expect module, and many other concepts as well. Delegate to was very useful because our requirement, as I mentioned earlier, we wanted a single playbook to set up one entire component with one primary and multiple secondaries. In these cases, we wanted to run few tasks on both primary and secondary, few tasks only on primary, few tasks only on the secondary. So that's where we have used delegate to option. While setting up components like X-ray, in X-ray configs, we wanted to provide machine IP, remote machines IP, where X-ray is running. So that's where we had used the concepts like Ansible default variables, especially variables like Ansible underscore host, Ansible OS type, all those variables we have used in our playbooks. And one more important thing is whenever we are installing the components, like it can be X-ray, it can be distribution, or it can be Artifactory, we used to run custom scripts. When we run that custom scripts, it used to ask a lot of custom prompts as well. To answer those custom prompts, we have used expect module. So to answer those custom prompts. So this is one of the good R&D that we did. And also, as I said earlier, I'm going to provide Ansible playbook that JFrog people have done. So there also they've used expect module to automate this custom prompts thing while they run custom scripts. Likewise, I had worked on a lot of other concepts as well. And also I have worked on refactoring of existing Ansible playbooks. So in one of the team, they were using a lot of Ansible playbooks, and they've written plain playbooks. So that's where they didn't use any variables or roles. So we went and we refactored the Ansible playbooks by using variables, and also we converted that playbooks into roles so that it can be reused across multiple teams. So these are the tasks that I had worked on in Ansible. Now let's discuss about containerization tasks that I've worked on Docker, Kubernetes, and Helm charts. One of the major activity that I had worked on was migrating applications and microservices which were deployed on a virtual machines to Kubernetes clusters. To containerize and deploy the application and Kubernetes cluster, so we used to follow multiple steps. So let me explain each and every step in detail. So first and very important thing is we used to have a call with dev teams to collect the requirements and to understand the application. Requirements as in application environment. So let's say, for example, if it is a Java application, so what kind of environment it requires? It requires Java 8 or a Java 11, all those application environment requirements we used to take, as well as configuration information, environment variables information, commands to build the application, commands to start the application, and also port information. Is there any specific port on which the application is running? So that is very important because that is required for exposing our service as well as like to open that particular port inside a container. So port information was very handy. So that's where we used to ask them to share the port information as well. And as well as we used to ask them to provide commands to test the application. Once the application is deployed on a container or in a Kubernetes cluster, is there any command or an API to test those application? So once we get all this information, we used to take a little time to understand the application and to understand the configuration. And once the understanding is done, so then we used to start writing a Docker file. So once the Docker file is done, by using that Docker file, we used to create a Docker image. So once the Docker image is available, by using that Docker image on a test Docker host, we used to deploy that particular application or a microservice. Once the application or a microservice is deployed in a Docker host, by using test APIs or like commands, we used to test that particular application deployment, whether it is really working fine or not. If that basic test API executes successfully, then we used to proceed with further steps. If that basic test is failing, again, we used to have a call with dev team to solve those issues. In many of the cases, it used to be a configuration issues, or like yeah, in some cases, it used to be a port issues, or sometimes like it'll be a issue with the test API that they have given. All those kind of issues, by having a call like this, we used to solve at this stage itself. Once the application is working fine in a Docker container, we used to start working on creating a Helm chart. Obviously, to prepare a Helm chart, we used to create manifest files for Kubernetes objects like deployment, services, config maps, secrets, HPA, PDB, and many other objects depending on the application or a microservice. Once the Helm charts are ready, so to test it, we manually used to deploy it on a test K8s cluster. If the application deployed in K8s cluster working fine, so then we used to modify existing pipeline. Or like if the pipeline is not there for any application or a microservice, we used to create a new one. So in that particular pipelines, we used to add steps related to Docker image creation, Docker image scanning, pushing image to the private repository and deploying onto the Kubernetes cluster. So once the pipeline is ready, through the pipeline, the application will be deployed onto the pre-prod environment or a QA environment Kubernetes clusters. So that is partially. Application will be deployed partially because we don't know how the application behaves with the actual load. To test the same, only few instances of the application will be on K8s cluster. Other application instances will be still on the virtual machines for a couple of days. In these couple of days, we will monitor application pods to check whether it is working same as VM or not. So while monitoring, the important metrics that we will gonna monitor were number of 500 errors, 400 errors, success rate, latency, memory utilization, CPU utilization, and number of restarts and other application errors as well. If the application is working fine, working as expected, from the partial deployment, we used to roll out complete application onto the Kubernetes cluster itself. After which, again, the application pod will be monitored for a couple of days. Again, the metrics will be the same, wherein like 500 errors, 400 errors, success rate, latency, memory utilization, CPU utilization, number of restarts, and many other errors of the applications as well. So while monitoring the application pods in the pre-prod and the test environment, we used to start preparing or customizing the same Helm chart for the production deployments as well. Again, same procedure. First, we used to partially deploy application instances to the prod, and then once that is fine, because pre-prod environment and production environment, there will be a slight change, right? So that's the reason. First, we wanted to do the partial deployment. So once if the partial deployment is working fine, so then we used to completely roll out application instances onto the Kubernetes cluster itself. If all these above steps are like whatever the steps that I've explained, if that are successfully done, so then we used to set up a meeting with the application team to educate them regarding the application on K8s cluster. So in cases of if they want to update any configuration changes, where to do it, how does those changes should be applied, and any known issues of the application we used to tell them, and as well as how to deploy the newer version of that particular application or a microservice, and many other things regarding the application we used to discuss in this handover call. So we used to call this phase as a handover phase as well, because once the handover is done, for only a few couple of days, we used to support the dev team in case of any deployments or deployment issues. So while working in this project, we were in agile mode. If you don't know what is agile mode, I would strongly recommend you to read concepts like what is agile, what is sprint, epic, tasks, estimation, who is scrum master, what he does as a scrum master, and burn down charts. All these concepts I would strongly recommend you to go through once. For now, to keep it simple, sprint in agile mode means it's a short term of a period wherein team works on to complete specific tasks or to complete specific milestone, or yeah, the team can work on some of the deliverables to deliver it to the client. So in our case, sprint used to be 2 weeks. Within these 2 weeks, in the beginning of the project, we used to take one application per sprint. But later, when we got adjusted with the team, so then we used to take two applications and we used to migrate the application from VM to Kubernetes cluster. Other containerization tasks that I'd worked on are creating Docker images for pipeline agents and helper container images. Usually Jenkins pipelines are used for CI/CD purposes, but it is not only for CI/CD processes. Jenkins pipeline can also be used for automating some manual process. Let's say, for example, we have a script. While running the script, user has to supply some artifact file or a config file, and all these artifact file or a config file, it should be there in the particular folder structure. For this a small process or a simple process also, we can use Jenkins and we can automate those small process also by using Jenkins pipelines. Also, let's assume for this script to execute, it requires a lot of third-party tools. In these situations, rather than installing all the tools onto the slave machine and running the pipeline on it, So better idea is to create a container, so which will have all the third-party installation, and then running the pipeline in that particular container would be the better idea. So that's where I've involved writing a Docker files to create a custom image for the pipeline agents. By using those custom images, if somebody wants to run a script, so they can use that particular image and they can create customized Docker agents, and then they can run their pipeline on that particular agents. And also sometimes for the application to run in KH pod, application expects some helper container running beside to the application container. In those cases also, I've worked on writing a Docker file to create a custom helper Docker image. By using that custom helper Docker image, we can create a sidecar container or a helper container. We have so many helper containers in Kubernetes. So that's where I have been involved in creating customized helper Docker image as well. Next task is migration, where we were deploying the applications from virtual machines to Kubernetes cluster that I had previously discussed was related to stateless application migration. But when it comes to stateful applications like MySQL, Postgres, MongoDB, and other cache systems were still running on the virtual machines. But client wanted us to explore moving the stateful applications onto the Kubernetes cluster. So that's where we started exploring the options. We started with stateful set. If you have a single instance of a database or a cache system, so then we can go with the normal stateful set and we can manage it. But if we need concepts like master slave architecture, high availability, and any other concepts, so then using a single stateful set, it would be really difficult to manage. Because in those cases like master slave architecture and high availability, we need to write the logic for all these scenarios. It can be replication of data from master to slave and automatic failure or many other things. We need to write the logic. And also it is not about the writing logic, so we need to also test it with multiple scenarios. That is also very, very important. So that's where after this complications, we thought to explore about public open source operators, so which will cover all our needs. So that is where we took down each tool that we were using it in that particular project. And for each tool, we noted down multiple operators. Let's say, for example, MySQL. So MySQL has a lot of operators. So we took down all the operators and we noted what are all the advantages, what are all the disadvantages, and also uh, what scenarios that particular operator will cover. So we had prepared a document and we have shared with the client. And also coming to operator, in a simple terms, if I want to say, there are two parts in operator. One is controller logic, so which will be a controller process that which will be running in our Kubernetes cluster. And other part is like CRD, we will say custom resource definition. So by using this custom resource definition, we will create objects. So it will be similar to deployment or a pod or any other object in Kubernetes. Similar to that, by using this custom resource definition, we can create an object. That object will be maintained and managed by some controller process, which will be a part of this operator. And when we go for operator, so all the logic, all this master slave replication, automatic failure, everything will be implemented and which will be implemented in the control process and will be managed by them itself. So, and also this was a POC. So once the documentation is done, so we have provided to the client, and then they will have a lot of meetings and then they will decide moving stateful applications to KH cluster or not. Coming to the next task that I had worked on in Kubernetes are Kubernetes admin tasks like creating a namespace, modifying the resource quota, and adding users to the namespace on request basis. In any project, none of the application will be deployed onto the default namespace. Every project will have different strategy, like per microservice, per a namespace, or like similar services in a single namespace. So different strategies depending on the project to project. In our case, it was a per namespace single microservice application used to deploy. So that's where whenever a new microservice is getting onboarded, we need to create a namespace and allocate some resources like CPU and memory. Also, every namespace will have a restrictions and resources. If a specific namespace needs more resources, then it should go through a lot of approvals. Then only we use to add or modify the resources of specific namespace. For all those namespaces, users will have only the read access. In case they require write and delete access, we used to get a special request. So that's where user had to explain about why he require read and write access. If that particular explanation is correct and legitimate, then by using roles and role bindings, we used to give a permission to a specific users. Other tasks that I'd worked on are application issues, like sometimes the pod used to restart with OOM error, out of memory error. So that's where we used to investigate why that's happening and suggest a solution. In most of the cases, application would have needed more CPU and memory to run as expected. So that used to be not there. So that's wherein like we asked users or like that particular team to request more resources. So once they get us the request, and then we used to add the resources, and then application used to work as expected without any OOM error issues. And also, I would strongly recommend you to read through some of the pod error states like config not found error, crash loopback, init error. So those kind of error states that if you know that, like then whenever you come across that errors, it is easy to solve those issues. Then other deployment issues. Few developers were onboarding themselves applications onto the Kubernetes clusters. As cluster admins, to avoid wrong manifest deployment in our clusters, we had enabled few rules. Like every pod definition file should have a resource block. Pod default user shouldn't be a root user, and mandatory liveness probe, readiness probe should be there. So all these rules we have enabled in our cluster, but developers were not following few rules. So they used to try deploying applications without following those rules. And then they used to raise the request to us saying that something wrong with the cluster. That's where we used to inform them about the standard rules that to check out before the deployment. So in many cases, they wouldn't know concepts like probes and default root user. So that's where our DevOps team used, and me also used to help them to deploy the applications onto the Kubernetes clusters. And this is very important in any organization. If they maintain Kubernetes cluster properly, so then they will enable these rules like default user shouldn't be a root user, and also resource block is mandatory, liveness probe, readiness probe. So these are the few rules that I've set. There will be so many rules in perspective to the service and other objects as well. Probe issues. Sometimes liveness probe, readiness probe used to fail due to invalid values provided in the probe configs. So that's where we used to investigate whether it's a issue with the path or like other parameters like initial delay seconds or timeout seconds. Also, sometimes pod used to be deployed on a non-responsive node, due to which the latency of the application might not be good. So if it is a node issue, so then admin team will gonna work on that. Or if it is a issue with the configs related to path, initial delay seconds, and timeout seconds, then we used to send it back to the developer and suggesting to do those changes. Config issues and permission issues. Few teams used to report whenever they use config map and tried copying the files to the folder where already they had few files. So it used to delete already existing files. So that is where we had to suggest to them to use the concept like subpath. So by using which, wherein like it used to copy the new file as well as it was not deleting the already existing files as well. And permission issues, script copied from config map onto the container by default. So for the container user, execute permission won't be there. For this, we had to suggest a workaround by copying the scripts onto the some temp folder first, and then from that temp folder to the Docker container user folder. So by which user can change the permission and run the script. It's not always that you'll be implementing and working on some issues. Sometimes we need to work on POCs and workarounds that might benefit development team or a client itself. So in my case, I had worked on a couple of POCs. Few of them are in our project. Developers were very comfortable with like VM-based deployments because whenever they need to change some configurations, they used to log into the machine and change it, and then they used to test those configuration. And while changing these configurations, they used to take the machine out of rotation and then they used to change it. But when we moved applications to K8s cluster, they wanted a similar workaround. So that time we did a POC by logging into the pod and making sure that the readiness probe fails. So that if readiness probe is not successful, so then pod will be out of rotation. In that time, so developer can do the config changes and test the configuration changes by sending request only to that particular pod. If request has to go onto the same pod. So then, so we used to use the concepts like port forwarding. So by using that particular concept, we can send a request only to a specific pod. And if the config is tested fine and like if it is working fine, so then so they used to do the changes to bring back the pod. So by making the readiness probe successful. And next one is, as I earlier mentioned, in our KH cluster, we had enabled few rules like having resource block in the pod definition block, mandatory liveness probe, readiness probe, container shouldn't run with the default root user, and many more rules we had enabled. So these rules should be followed by everyone who want to deploy the application in our KH cluster. But unfortunately, many teams were not following that, and they used to deploy the application in KH cluster, and then they used to know that so there has to be followed some rules and all. Because of this, a lot of rework they had to do. So to avoid this lot of rework, we wanted to explore a tool which identifies the misconfigurations at the early stages. Like even when a developer wants to check in Helm charts or Kubernetes manifest files onto the GitHub, right? Before that only we wanted to identify are in cases wherein like if even if they push the wrong Helm charts or like Kubernetes manifest files, in the CI/CD pipeline, at the beginning stages only, we wanted to identify all those misconfigurations so that they can save a lot of rework and as well as like they can save the time and they can do the changes at the very beginning and then deploy the applications without any issues. So that's where we had come across a tool which is called as Dartree. Dartree is one of the tool, so it identifies the misconfigurations in Kubernetes manifest files and also in the help charts, which can be used as a Git hook, or like you can use it at the Jenkins pipeline, or like if you're using any CI/CD tools like GitHub Actions or like Azure Devops. With that also we can integrate and we can identify the misconfigurations. If you want to know more about Dartree, so I had made a separate video on that. So I'm gonna provide that video link also in the video's description. You can go ahead and check it about Dartree in detail. Also, sometimes our client used to ask us to explore on new Kubernetes objects like PDB, network policy, and many other objects. Whenever we wanted to explore these kind of objects, so we used to deploy these objects with our applications to test it with different scenarios. So once that is done, we used to cover all the scenarios and we used to capture all those test cases and testing that we had did in a doc format, and then we used to share it with like client manager. So then further discussion they will do on that, and they will decide whether to take that particular object into the consideration or not. Next is ephemeral container. As I said earlier, our developers were very much comfortable with VM based deployments because whenever they want to debug or monitor some processes, they used to log into the machine and then they used to do those activities. But in Kubernetes cluster, we wanted to keep our application container image as lighter as possible. So that's where we didn't wanted to install any extra command line tool on that. But if we install that command line tools, our image application image becomes very heavy, and that will be really difficult to manage. So in a future or like long-term perspective. So that's where we come across a container which is called as a ephemeral containers. So ephemeral containers are very useful. So in interactive troubleshooting, when kubectl exec is insufficient because of container has crashed, or like in cases of container image doesn't include any debugging utilities, in those cases, right, we can use ephemeral containers and attach to running pods so that like by using whatever the utilities there in the ephemeral containers, we can execute those commands and then we can monitor like manage processes which is there in the application pod or a container. Now let's discuss about Jenkins tasks. As I mentioned earlier, Jenkins is not only for automating CI/CD. It can be used for automating some manual processes like executing some script, installing some packages, updating patches, start and stop some specific service, and other simple processes too. So I was involved in automating execution of a few scripts and as well as like start and stop of few specific services as well by using Jenkins. And next one is migration of pipelines from freestyle job to pipeline job. In one of the project, so it is I would say like back then like 4 or 5 years back. So people used to use freestyle jobs. So that's where as a migration we wanted to convert all the freestyle jobs into the pipeline jobs. And also we wanted to make sure that whatever the pipeline that we create, it should be used across all the teams. So whenever if there is a change also, it should be very minimal changes. So in that way, we made sure that we have some standardized Jenkins file will be used across multiple teams. And so this point, so in Kubernetes task itself, I've already discussed as a part of app migration to the containerization. So we have modified the pipelines by adding the stages like Docker build, scanning Docker images, pushing Docker images to the private repository, and static code analysis of a Helm chart and Kubernetes manifest file, and also a stage to deploy the application onto the test case cluster. And also we had a separate CD pipeline to deploy the application onto the Kubernetes prod cluster. So all these changes we have made it in an existing pipeline. And also if a pipeline is not there for a specific application, then we used to create the whole new pipeline, which will have these kind of stages in that particular pipeline. The next task is as a part of operational activity, we wanted to upgrade Jenkins on a regular basis. It is one of the famous tasks in Jenkins as well. So while upgrading, the challenging part is to make sure that, so what is a stable version of Jenkins? Because day in, day out, Jenkins, people will gonna release the newer version. So we need to read about the release versions, release notes, and all those things. And we need to identify which is the stable version. And it is not only identifying the stable Jenkins version. So you need to choose Jenkins plugins also. So whichever which matches are compatible with that particular Jenkins version. So once you identify both of them, stable Jenkins version and plugin version, which will go well with that particular Jenkins version, so then you can go ahead and you can start the Jenkins upgradation process. And also this upgrade depends on the way that you have installed. So if you have installed through containers, and then the upgradation process will be different. And if you have installed Jenkins as a service, so then the upgradation process will be different. In our case, we went with Warfile Jenkins installation. So whatever the few steps that I'm gonna mention next, which will be only valid for a Warfile Jenkins installation only. So if, as I said earlier, so when if it is a different installation, so depending on that installation, the upgradation strategy will gonna be different. So in our case, first we used to stop Jenkins server and then take up a backup of Jenkins home directory. So we used to have a backup always of a Jenkins home directory, but for extra cautious, so wherein we used to take the backup of Jenkins home directory again, and then so download newer Jenkins version warfare. So replace it that new Jenkins warfare with the older warfare. So it will be there in the Jenkins home directory. So once that is done, start the Jenkins server and monitor the Jenkins logs. If you see any issues, so then again, we need to work on that particular issues. If it is not, so then that is fine. And as I said, it's not only that you need to make sure that Jenkins server version is upgraded. You should also make sure that plugins also should be upgraded with Jenkins upgradation. So once Jenkins server is up and running, so then by going to manage Jenkins, and then we used to upgrade all the plugins. After upgrading Jenkins also, we used to monitor for a few days to check whether all the pipelines are working without any issues or not. So if we see a lot of issues, so then we used to roll it back and then again work on that upgrade strategy. And then after a few days again, used to upgrade the Jenkins back to a specific or a stable version. And also, it's not only upgradation. Sometimes we used to get a request to install and configure a specific plugin. So on a request basis, we used to work on that. So we used to install and we used to ask them what are the configuration that a particular plugin needs. So we used to take that configuration steps and then we used to configure in the Jenkins as well. And the next task is so in one of the project where we were working, the client expectation was to adopt all the best practices. So that's where we adopted few best practices like deleting our old build logs. So which helps us in saving the memory of the master machine. So master Jenkins machine. And so the next one is timeout for every job. Else we have observed that some jobs will get stuck because of that other pipelines which really requires a resource won't get, and that will be there in the queue for a while. So that is not correct. So that's where we wanted to have a timeout. So if that timeout has been crossed by some pipeline, so then it will be aborted and the resources will be given to other pipelines which are in the queue. And also we wanted to make sure that whatever the common things that we have it in pipeline, we wanted to create it as a shared library so that like it will be easier for us to manage it. Because if let's assume there is a change, a small change in that particular part of a code. So if we don't have shared library, so then we need to go for each pipeline and do the changes in the each pipeline. But in case if we have a shared library, so it is like if we do the changes in some places, as shared library is referred in all the pipelines, right? So if we do the changes in shared library, so then it will gonna take effect in all the pipelines. So that is where for the better manageability, so wherein like we went with shared library. Now let's discuss about monitoring tasks. As we were deploying applications on Kubernetes cluster, monitoring app metrics and cluster metrics were very important. In our case, for both app and cluster metric monitoring, we were using Prometheus and Grafana. At the beginning of the project, we wanted common Prometheus and Grafana for both app and cluster monitoring. But when we onboarded multiple application teams, managing access and creating a dashboards for app teams and like cluster admin teams were very difficult. So that's where we wanted a different monitoring stack for application team, a different stack for admin team. So I was involved in the segregation, and also I was involved in a few monitoring admin activities like adding data sources in Grafana. Few data sources that I've added are like Prometheus, CloudWatch, MySQL, InfluxDB, and many other data sources also I have added in Grafana. Also, I've worked on Prometheus related admin activities like adding endpoint details, custom rules, and also adding alerts into the Prometheus configuration. So once those configurations are added, so we used to restart Prometheus to apply those configuration changes. And if you don't know what Prometheus is, if you want to learn Prometheus from the basics, so then I have a playlist. So you can refer that particular playlist. I'm going to provide the link in the video's description. And also sometimes we used to get requests to create a custom dashboards in Grafana. So which will have metrics related to pod resources, number of restarts of a pod, number of 500 errors, 400 errors, heap memory of the pod, and many other metric related dashboards we used to create it. And that's it for this video. If you have liked the video, please like, share, and subscribe. And one more thing, if you have any question regarding the task that I've discussed in this video, please do comment it. I'm gonna try to answer those questions. And if I get much support on this video, I'll do more and more videos like this. And so that's it. Thank you. Have a great day.